In this part of the lesson, we are going to talk about right triangle similarity and the right triangle similarity theorem. So remember, we already talked about similarity last chapter. That's when two shapes, or when two polygons or triangles or whatever are the same shape, but not necessarily the same size. So we're going to be dealing with right triangles that have the same shape, but not necessarily the same size. What makes this a little different is that the triangles are going to be kind of inside of each other. It's going to be made with an altitude. So the right triangle similarity theorem says, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if you take a look at this diagram down here, we have triangle ABC, right? This whole triangle here. Triangle ABC. Okay. But then this altitude is drawn right here where BD is. Now what that does is it splits your triangle into two parts. We now have two other smaller triangles sitting inside of it. We have this kind of medium-sized triangle right here with ABD. And then we have this very small triangle right here with DBC. So our one big right triangle now has become three right triangles. So what I have over here is it kind of drawn separated for us. So we have our original triangle ABC. And that's going to be similar to the two other triangles, so we just need to figure out the appropriate way to name this. So in the original, I went A to B to C. So that's starting at my smallest angle, down my longest side, to my shortest side. So I want to follow the same pattern when I name my other two shapes here. So if I take a look at this medium-sized triangle here, I am going to start at A again because that's my smallest angle. I'm going to go along my longest side and then from there to my shortest side. Or not my longest side, but the one that gets me to my right angle. So if I want to follow that same pattern, I would call this triangle ADB. And then for this smallest triangle here, again, we need to follow that same pattern. So I'm going to start at my smallest angle, which is B. I'm going to go down to my right angle, which is D, and then across this short side to C. So we would call this smallest triangle, triangle BDC. So these three triangles are similar. That means their sides are going to be in proportion. So this says identify the three smaller triangles in the figure. Redraw the triangles and reorient them to show the corresponding sides. So we have this large overall triangle here, and we can name it in whatever order we want. Okay, so just because this is kind of the way it's flipped around, I'm going to call this first one, I'm going to just redraw it completely by itself. Here's my right angle. I had a Y up at the top. My right angle is X. And then this angle over on the right is Z. So I'm going to call that triangle Y, or it doesn't, I guess I don't care what you start with. We can start with the right angle and I'll go in alphabetical order. That would be X, Y, Z. And then I'm going to do my squiggle for is similar to. And now I want to look at my medium-sized triangle. That's right here. It has vertices of X, Z, and W. But I have to figure out the appropriate way to write this. Now this is kind of flipped upside down. So what we're going to do is we're going to flip it around so it's facing the same way as my first triangle. So like this. So if you take a look at our picture, where my little right angle here is, that's W. And then where my short side here is, that's X. And then that would be Z. So we would say the triangle XYZ is similar to, so remember when we named our first shape, we started at our right angle, we went up along this short side to Y, and then across our hypotenuse to Z. So we want to follow that same pattern here, and we would start at our right angle, which is W, up to our short side, which is X, and then across our hypotenuse, which is Z. So we would call this triangle WXZ. And then is similar to, and now we want to draw our smallest triangle, which is right here, that has vertices of X, W, and Y. So we're going to flip that around too. So it's again facing the same way. My right angle is at W again. Then my shortest side here goes from W to Y and across that hypotenuse to X. So that's how that would be labeled. So then when I name this, we again want to follow that same pattern. Start at your right angle, which is W, to Y, across your hypotenuse to X. So triangle WYX. So why this is important is because we're going to need to be able to identify our corresponding parts to set up proportions here. So you're going to need to be able to identify the different triangles. And something you're going to hear me say a lot is the short side, the long side, and the hypotenuse. So each right triangle is going to have a shorter side, a longer side, and a hypotenuse. So in these triangles, like in this first one, this blue one, XY is the short side. In the orange one, WX is the short side. In the green one, WY is the short side. Right, so they all have a short side. So those lengths go together, they correspond. In the blue triangle, the long leg, or the long side, is XZ. In the medium triangle, the long side is WZ. And in the small triangle, the long leg is WX. So those all correspond with each other. And then each one is also going to have a hypotenuse. In my bigger triangle, this blue one, YZ is my hypotenuse. That's going to go with the hypotenuse in my orange triangle, which is XZ. That's going to go with the hypotenuse, which is YX. So we're going to have to be able to identify those different things in each shape. Okay, so that is what we're going to be doing on this next side here.